Welcome back to The Explainer. So, we touched on the basics of washing back in Section 2, but today we're getting right into the nitty-gritty operational details of how exactly we clean a massive, high-tech jet-class compressor. If you've got an aeroderivative gas turbine humming away on your site, keeping it clean isn't just about making it look nice, it's absolutely critical to its performance.
I mean, really, how do you clean a jet engine? You can't exactly run it through the local car wash, right? Well, here are the stakes. Every single day this engine runs, it is literally breathing in dirt, salt, and soot from the surrounding air. And as that fine layer of grime coats the compressor blades, the engine is silently bleeding power and efficiency.
To fix this fouling problem, engineers actually developed two distinct wash procedures. 2 washes, 2 jobs. And mixing up when to use which one, honestly, it's a super common rookie mistake in the field. The crucial thing to understand right out of the gate is that these are 2 distinct engineered solutions matched to 2 completely different situations.
Think of it like this. It's the exact same difference as rinsing a dinner plate under the tap between uses versus properly soaking a heavily baked-on roasting pan overnight. You wouldn't try to deep clean a crusty roasting pan with just a quick 2-second rinse, would you? And conversely, you wouldn't take your whole kitchen offline just to rinse a single plate. Keep this analogy in the back of your mind as we explore these 2 tools.
All right, let's dive into our first method, Section Online, also known as the quick rinse.
The absolute defining rule for an online wash is this number right here, 1.5 megawatts. The turbine has to be operating above roughly 1.5 megawatts of load for this process to happen safely. Why? Well, because you are spraying water into a running jet engine and you need to be totally sure combustion stability isn't disrupted at low power.
Once you hit that threshold, the online wash is fast. Like, incredibly fast. It's an automated fixed cycle that blasts purified, demineralized water and detergent right into the compressor. And the whole thing, it takes roughly 9 minutes.
The automation sequence is completely hands-off once you initiate it. First, the air supply solenoid opens up. Next, the pneumatic pump drives the wash fluid. Then, the spray solenoid energizes for a precisely timed blast. Finally, auto shutoff. And remember, this entire sequence is happening while the engine is fully spinning, burning fuel, and generating continuous power for the grid. But what happens when that quick rinse just isn't enough? That brings us to Section Crank Soak, the deep clean.
Sometimes the roasting pan is just too dirty and you absolutely have to take the kitchen offline. The crank soak sequence is a much heavier, much more deliberate process. First, the engine has to be completely shut down and cooled. Then, instead of running on its own power, it's motored slowly, at about 1200 RPM, using just the starter. A larger volume of detergent is sprayed in, the starter is de-energized so the rotor coasts, and the solution is allowed to really soak before being flushed out with repeated clear water rinses.
And unlike that speedy 9-minute online wash, this soak period is non-negotiable. You're generally leaving that detergent sitting there for about 30 minutes. The slower motoring speed, combined with this extended soak time, allows the chemicals to actually penetrate and loosen up the stubborn, baked-on deposits that a quick online spray could literally never touch. Then, you just rinse it repeatedly until the drainage runs completely clear of soap.
Okay, quick pivot to Section, the hard limits, preventing catastrophe.
If you recall the thermal shock warning from Section 2, you know doing a crank soak at the wrong time won't just fail to clean the machine, you will instantly destroy it. Pay close attention to this number, 200 degrees Fahrenheit or about 93 degrees Celsius. This is your strict thermal shock limit. You must never, ever, start an offline crank soak wash until you've confirmed the outer compressor casing has cooled below this threshold.
And here's exactly why this matters. Cold water plus a hot casing equals permanently warped metal. It's just simple physics. It's exactly like taking a hot glass baking dish out of the oven and plunging it into an icy sink. That uneven, sudden cooling is going to permanently warp the metal compressor casing. The catastrophic consequence here, the very next time you start the engine, those tightly fitted compressor blades will instantly rub against the warped casing. A delayed wash costs you a bit of time. A warped casing costs you a multi-million-dollar engine.
So let's see how this all builds into a real-world application. Section, making the right call. Let's test your knowledge.
Picture this. You're standing in the control room. You notice the unit load is sitting at 1.2 megawatts. The online wash button is flashing on the panel, suggesting it's time for routine cleaning. Do you initiate the automated online wash sequence right now?
The answer is absolutely not. Remember our threshold?
The unit is below the typical 1.5 megawatt minimum required for an online wash. Initiating the spray right now is a dangerous mistake because it could seriously disrupt combustion stability at this lower power level. Your best move here is to either wait for the grid demand to bump up your load or just plan to take the unit offline for a proper crank soak wash instead.
Let's quickly recap this side-by-side so you walk away with a perfectly structured mental model of these two protocols. For the online method, engine is running, takes about 9 minutes, and it's used for routine, quick rinse upkeep. For the crank soak method, engine is shut down and cooled below 200 degrees Fahrenheit, takes roughly 30 minutes plus rinsing time, and it's used for deep cleaning, stubborn fouling.
The ultimate takeaway here is that these two tools are complementary. They are not interchangeable. Using regular online washing between your deeper offline crank soaks is going to measurably improve the sustained efficiency of the compressor over its entire lifespan. So, I'll leave you with this thought. The next time your compressor breathes in a heavy load of ocean salt or industrial soot, are you just going to rinse the plate or are you ready to soak the pan? Knowing the difference makes you a master of the machine. But what happens to this exact wash chemistry when the temperature outside drops below freezing? Well, that is a whole different puzzle. Join us next time as we dive into cold weather chemistry and antifreeze ratios. Thanks for exploring this with me.